So good morning, everybody. I am Herve Ribot. I am Micro and Nanoelectronics Director at Minalogic Innovation Cluster, which is the French regional cluster of Rhône-Alpes. So it's Grenoble, of course, but not only Grenoble, also Lyon and Saint-Étienne. So I have the pleasure today to walk you through this journey across strategy and business creation. And I will do so with my colleague Wolfgang Gessner. Maybe Wolfgang, I think many people know you already, but if you can shortly introduce yourself.
Yeah, Wolfgang Gessner, good morning. I'm working with VDI/VDIT, and today I'm here as the director of EPoSS, the European Technology Platform on Smart Systems Integration. EPoSS is a co-organizer of this event, and on behalf of EPoSS, also my welcome to you. And yeah, I will assist Herve in today, and yeah,
okay.
I give back the floor.
Thank you, Wolfgang. So what will be the program this morning? We will start with something you know already, which is functional electronics, but Petra will show us how functional electronics can first help digitalization, but also have a positive impact on society and, most importantly, an environment, which is a very peculiar way to look at things and maybe new. And then we will continue with methodology. It's a question we have every day in Innovation Cluster. How can we help companies to do digitalization and bring their technology and product to market, especially in the field of smart systems? So you will have a presentation about the DigiFed European program, and then Blumorpho will share with us what they know are best practice to foster innovation in the field of smart system, especially for SMEs. And then there will be this question about education and training. We thought with the committee that it's a hard question, how to bring young people into the field of smart systems, what should be the menu in engineering schools, and you will see universities joining forces to create what we thought was an enticing master program for young people to entice them into this field of smart systems. And we will end up with a kind of celebration, the 5E contest result. And it will be also, I think, an opportunity to see three concrete and I hope compelling examples of how functional electronics can be used to make a smart system. So I think we can start with the first talk by Petra, which is entitled Functional Electronics, Transversal Enabler for Europe's Digital Transformation and its Transition Towards a Circular Economy. So Petra joined VDI/VDIT in 2009. Then she became head of section Smart Systems and Multimodal Mobility in 2008. And most recently, she became head of Department Mobility, Energy and Future Technologies. And she is very knowledgeable about coordinating EU-funded CSA programs on smart systems, integration and hardware electronics. So Petra, the floor is yours.
Thanks so much, Herve. Always a pleasure to speak at SSI and always a challenge to fit all the content into a few minutes. And particularly this year where I only got 10 minutes, as I learned. So the challenge is to tell you about functional electronics and in particular about a meta roadmap that we developed in the project 5E. And I have to say that I concentrated on only a quarter of all the content. but be assured that the content is available on our website and accessible to everybody. So whatever you are missing, it is there. It's just a matter of going to the website and finding it. So the 5E project is an EU-funded CSA project under Horizon 2020, and we have a focus, as is said here, on the 3 electronics hardware areas: nanoelectronics, flexible organic and printed electronics, and electronic smart systems. We are looking into these 3 areas, and in particular at how these strengths of these 3 areas can be combined to exploit new innovation opportunities for electronics. We have a focus on EU competitiveness, industrial competitiveness in particular, and we have been aligned with the EU strategy on electronics with its particular points on sovereignty, skills development, co-design, manufacturing capabilities, and large-scale investments. We have also been aligned with the EU Horizon Europe clusters and the areas of intervention. So the idea is to make visible the role of electronics in the digitalization of European industries, and not only making visible, but also position electronics as fundamental in that domain. And we do that by federating the 3 electronics communities, by developing a joint vision and the respective meta roadmap, and also by increasing outreach and visibility. So a bit of showing off. As coordinator of this project, we have already some very tangible impact in the project. Our concept of functional electronics has been taken up into the work program of Horizon Europe Cluster 4. It's also included in the ECSS RIA edition of 2021. And we have, out of one of the vision papers that we developed, created a task force in EPoSS on green ECS. 9 key deliverables. We have a catalog of 39 opportunities, a vision based on functional electronics, 4 vision papers, a meta roadmap, and the digital showcase that we will learn more about later on. We did that all in consultation with over 250 stakeholders who gave us their input and also their expressions of interest. Now, this is a bit of a methodology, but just to show that we concentrated in our approach on functionalities and looking into a lot of sectors, 13 sectors, included many stakeholder consultations, so that it became a top-down and bottom-up combined approach. What is important here is this little bubble diagram in the left side, where you have the 3 electronics areas, and it's important to mention that we looked at the interfaces here. So the catalog of 39 opportunities, I cannot go into detail, but as I said, it's all on the website. You have a one-pager for each of these opportunities, which gives you technologies, applications, challenges, and opportunities. And for each of them, you have a headline that already describes basically the content of the one-pager. We combined that, or we matched this with the political level, with the global challenges, with the clusters in Horizon Europe and the areas of intervention, and then arrived at what we call functional electronics as something that is at the center of the vision for the electronics areas in Europe. We found that there is this something at the convergence of the 3 areas that is transversal across all sectors, across all areas, that brings together 6 important features and has the potential of differentiating and giving a competitive advantage to EU electronics industries. So we put the functional electronics concept at the center of the joint vision. The 6 features that I mentioned, these are important, are the shift from physical to functional integration, the use of novel substrates and structural systems, the eco-design approach at product, process, and business model level, the real-time capture and management of multi-physics data and contextual information, and the networked and autonomous operation, which is often complemented by software solutions, including AI, and the seamless integration in everyday objects, and that in a broad spectrum of applications. So from there, we described 6 areas of societal relevance where functional electronics plays a central role, and described these in 4 vision papers. There is one that I will go a bit more into detail, the one on circular economy. There is one on energy, one on autonomous operation of machines, and one on future sensing. I will come to that in a bit. So this development of the meta roadmap based on the vision papers, we wanted to make sure that we have a topic for recommendations that is very tangible, then also to address the issues that came out of the catalog of opportunities and say which ones are covered. We did a rating, Eisenhower rating of importance versus urgency. We addressed the stakeholder groups, the targeted stakeholder groups, and technical as well as non-technical barriers, and we mentioned, where applicable, the funding scheme. So here we arrived at 15 out of 45 recommendations that are both important and urgent, and we went into more detail for those. So we have the 4 modules of the meta roadmap corresponding to the vision papers. The one on circular economy, you will learn a bit more later on. Then energy, where we have 5 recommendations evolving around real-time computing, energy efficiency, energy harvesting approaches, high performance and compact power electronics, then smart energy management. In the autonomous operation of machines, we have in particular the AI liability issues, but also novel sensor systems that can act on quickly changing situations. We have the edge AI for the first 2 autonomy levels, and something more horizontal, which is the centers of knowledge transfer. For the sensing, we looked into 4 areas of application. One is the driving or self-driving cars with the fast-changing conditions. Another one is environmental monitoring, sensing systems, then sensors in medical application, and the data acquiring sensors for IoT applications. We also identified 2 horizontal topics of great importance and urgency, and one is the reliability aspect, and the other is that we wanted also to go in the direction of other technologies. So it's from functional electronics towards other KDTs like the integrated photonics or the quantum computing. So as I said, a bit more on this functional electronics on the transition towards a circular economy. Here we look at the twin transition actually of green and digital, and look at the 2 plans, action plans of the EU, one on the circular economy and the other on the new industrial strategy, digitalization. One cannot go without the other, and if we want to unlock the potential of digitalization, we also need to look at developing safe, sustainable, and low carbon solutions. So what we did is we looked particularly at this left side, the green side, with the clean material cycles, with the eco-design approaches, the circular electronics initiative, and the sustainable product policy framework. And the 2 main things that emerged were to ensure sustainability is put at the heart of each and every solution containing electronics, and to accompany this by a proper and meaningful regulatory and legislative framework. So you have the sourcing, the sustainable and responsible sourcing of raw materials. You have the energy efficient manufacturing processes. You have the optimized use of resources, the famous 6 R's, or even maybe 7 R's if you include the responsible eco-design. You have the traceability aspect with the product passport and the end-of-life enhanced management practices. So this all comes into longer recommendations, as I mentioned before, and I will not go into detail here for timing reasons. But as I said, it's all there, and go to the website, download the vision papers, have a look at the content there. So eco-design and sustainable product policy framework were the 2 main recommendations in the meta roadmap, all around functional electronics. Then another key deliverable of the 5E project is the digital showcase. We will learn more about that later on by my colleagues Serena and Fabrizio. I would also like to mention that we have topic tables for deep dives into our 5E meta roadmap modules, particularly the ones that I couldn't develop further in this talk. The one on the energy solutions today, later on at 12, and the one on functional electronics and future sensing on day 3. And we have another one looking deeper into circular economy on day 2, also around noon. With that, here a few links. You will get the slides so you can click on them later on to access the key deliverables. And with that, the consortium is smiling and waving and saying thank you for this opportunity, and I'm open to questions if time allows. Thanks a lot.
Thank you. Thank you so much, Petra. Yes, we have time for a few questions. I forgot to let you know that you can ask your question using the chat during any of the presentation. And of course, we have also 2-3 minutes after each presentation to take your question, so you can raise hand and just ask your question now if you like. Any question at this stage?
Too many words.
It was very clear.
I have one question, if you allow Herve and Petra.
Yes.
Who are the addressees of the vision papers?
Mostly public authorities, because it's about recommendations for funding, but it is also very relevant for industry and academia and RTOs as well.
Okay.
So there's also some long-term aspects in it, some priority setting. Yeah.
Okay. Thank you.
We have a
Petra.
question.
There is one.
Oh, yes, there is another one.
In the chat.
Yes.
Yeah. Can you elaborate a bit on the concept of product passport from Regis Hamelin?
Yeah, I can say a few words on an example from the battery context. So passport is a sort of a digital twin that follows or accompanies any product along its whole lifetime. So with all the relevant information on materials use, on second life, on recycling, on, yeah, basically anything.
Okay.
That was a tricky one, Regis.
Okay. Thank you. I think it's time to move on to the next talk. Thank you so much, Petra. So we'll talk about 5E anyway again at the end of the morning. So next talk is by Bastien Hualpa from Minalogic. So Bastien is DigiFed project manager at Minalogic, and he has some. He's a young guy, but he has some experience in European affairs and SME support. And he will give us an outlook of where we are with DigiFed in terms of supporting companies and what methodology we use in this project. So Bastien, the floor is yours.
Thank you, Herve. So I believe next step will be to share my screen. And the tricky part is to achieve opening it full screen and that everybody sees it. So can you confirm that you see my presentation?
Yes, it's fine.
Yes.
That's great. That's a one-shot achievement. Great, thank you. Thank you for this presentation. So I will be talking today about, I'm sorry if I'm looking up because I just realized my presentation is second screen, but I will not try right now to fix that. So today I will talk about a project, Horizon 2020 project called DigiFed on digitizing Europe industry. And we'll be talking about the different experimentation support instruments that we have on that project. So my pretension today is not to give you a masterclass of European project, is not to talk about innovation or system, but to give you an overall approach, a mentality that we try to achieve within DigiFed. First, a small word about Minalogic. I hope that my colleague Herve didn't already introduce you about Minalogic and you still have some questions and curiosity about the cluster. So we are located in Auvergne-Rhône-Alpes and we have 3 offices. We have one in Grenoble, well known for his microelectronics. We have in Lyon and we have in Saint-Étienne. Just to give you a full overview about Minalogic, we cover the full entire chain or value chain of digital. We, as you know, digital now touches everything and every market. So we do address all kind of end markets and we have 2 main missions. We have business and innovations, and behind that we have several services that we provide to our members and to our partners. We represent around 450 members. As you can see, we have 4 main topics: electronics, photonics, software, content, and use. But now let's talk about DigiFed. That was just to give you an overview about who I am and where I work. So DigiFed is an Horizon 2020 project. We have 12 partners that we can maybe classify on RTOs, large companies, and business support organizations. On the RTOs, as you can see in front of you, we have some of the main ones in Europe, which provide more technical expertise. Then we have large companies, and when I say large companies, I'm talking about ST Microelectronics, both France and Italy. And then we have business support organizations, which is Blumorpho, Digital Catapult, Minalogic, Zabala. We have 8 million euros budget, and as you know, as a cascade funding project, half of the money is going to finance directly the companies. So we are coming from the initiative called Smart Anything Everywhere, and this initiative englobes, it's a framework of different innovation accents, each one having a specific technology and a specific market. And this is the interesting part. It's about finding the right technology and addressing the correct market. So to support, in order to support the companies in this competitive process in integrating new technologies, we have decided to have a multi-approach scheme, having both the technology and the market. We're trying to find this right balance between technology offer and market demand, between being technology pull and market, well, technology push and market pull. So this is the kind of answers we're trying to figure out in DigiFed. And to answer to those kind of questions, we have decided to provide different business support, different mechanism support. We have 3 main ones. We had the first one, which is the application experiment. So application experiments, the first 2 ones on the list can be either single or twin. The single one is projects between RTOs and companies. Please bear in consideration that every time I'm speaking about companies here, I'm talking about either SMEs or midcaps. And then when I'm talking about RTOs, I'm talking about RTOs and large companies within DigiFed. So we have the application experiment single between an RTO and a company, but we have also an application experiment twin between 2 companies. That was also a scheme that's interesting. It is to supporting the synergy between 2 companies. between two different companies from two different countries. This is a very important criteria. We do not support collaboration between companies from the same country, but from different ones. Then we have the generic experiment. This is more like a conception between RTOs and companies. This could be seen more as a technology push. It is an RTO having a need, but requiring to have the market appliance. In that framework, what we do is we identify companies, group of companies in Europe having a same problematic, a same need, and we put them in contact with an RTO. Then there will be a process of co-innovations together to develop technology on a specific market. And the third one is what we call the digital challenge, which is basically open innovation between a large company and a company which is either an SME or a mid-cap. This is also very interesting because it wants to address a specific market need from a large company, and to look and to scout for solutions within SMEs of our ecosystems. So it is interesting for both the large company because it provides them a wider ecosystem that they know. They might tackle challenges and provide them with solutions they haven't think about. And for the small company, it's interesting because it provides them at first contact with a large company, which, as you know, it's not easy to work with large companies. A lot of process and there's a lot of dimensions that you have to take into considerations, but also it potentially opens a large market for the company. So, some details about these different innovation pathways. As you can see, you have on the partnerships line the different configurations that you can have. You have the envelope and the money grant that is involved. Each of the support schemes have different thematics approach, will still being on the physical system thematic, which is, to simplify, it's having a relation between hardware and software. But for instance, for generic experiments, we have specifics, RTO technology push needs, as you can see in front of you. And on the digital challenge is much more open. It's about exchanging with a large company and also identifying together the kind of challenges they want to tackle. On the criteria, we're on the classic ones, excellent impact implementation. So the project have to prove that there's an innovation part of it. They have to prove that they will reach the market. That's why the impact and the business aspects are very important to us. And then we have the implementation, which is more like the partnership and the definition of the work plan coherence. On the gender experiment, which is important, is to have a company consortium with the same global needs. And from the digital challenge, as I was saying, we're more tackling like a specific market need. The results, prototyping, application experiment, third generation product. The idea to have a smart solution integrating the CPS technologies. Which is very important for us is that beyond the funding, because we do understand that the companies need funding to develop, to innovate, but beyond that, we also want to support them with the right elements and the right tools to reach the market and to sell. So two kinds of support. We have the innovation management support with different assessments, with different, classroom and coaching. Sorry, I was looking for the word, coaching, to go to the market strategy, to reach the market, to have also to access to private and public funding, because this is a start for them. Having the opportunity to have our support to have some funding from the European Commission, it's a starting point. But then there's all the rest of the adventures they have to reach. So on that process, we also want to assess them in additional public and private support. We have also what we call the labelization process. It's also having the support of business services organizations / clusters to provide them with the right inputs to improve their projects. And also business support. Business support can go through different activities. As you know, there is business meetings. That is a great way for companies to contact potential partners. And it has also open innovation. Open innovation, as you might know, it's about exchanging and it's about thinking together how we want to innovate and how we want to integrate new technologies in our services, in our products, or in a way of manufacturing. So that was to give you an overall idea of how we want to approach and how we want to support companies. I'm at your full disposal if you have any question. Thank you.
Thank you, Bastien. We have time for a few questions. Oh yeah, there is a question by Louis. How approaches like DigiFed fit in a broader context with DIH, Digital Innovation Hub? Can you tell us something about that, Bastien?
Yeah, that's a great question. I might say that the name DigiFed includes DIH name. The idea of the DIH work package is to provide sustainability on the actions that we do. As you know, there is currently an evolution on the DIH and potential EDIs, and the idea is to provide with both regional ecosystem, elevating to the European ecosystem. And that's what we're doing on DigiFed. We are first focusing on our strength, in our DigiFed consortium strength as DIH. And the next steps, as you know, is to expand and to create links with external DIH. So if you have any specific need or request concerning the DIH system, market, services needs, market demand, or strategic approach, you're more than welcome to exchange on that topic.
I don't see any. Maybe one question for me. How competitive are the different instruments? What is the success rate for SMEs that apply to this program?
So it changes. It depends on the application experiment. The success rate is around 25%. But when you have the support of some of the partners, it goes up to 60%. This is, of course, because the companies that have a link with a partner of the DigiFed consortium has the opportunity to exchange and to improve their submissions. For the digital challenge, an important step is also to provide service to the large company. So we do that two-phase selections. So I would say that the success rate, it's lower. It's around 15 or 20%.
Okay, thanks. I think we are good, Bastien. Thank you very much for your presentation. We'll continue with exchanging about best practice at European level to foster digitalization and business creation. So this time, this will be Blumorpho and Regis. Good morning, Regis, who will share with us what he thinks are the best practice at ecosystem level. So Regis has a PhD in electronics from the University in Lille. I can testify he has a real experience on startup creation because Regis co-founded Intexis Photonics in 2003. Not at a very good time, but he did it. And then in 2010, Regis joined EPoSS to work in the Cowin team. It was a support action, FP7 support action to speed up commercialization of technologies developed in the frame of smart system cores. And Cowin led to the foundation of Blumorpho that Regis joined in 2015. And so you can see that Regis is really an expert in innovation management and support to startup and SMEs. So Regis, the floor is yours.
Thank you very much, Herve, for the introduction. And thank you for having me today. So you should see my screen now?
Yes.
Okay. So we are currently in the transition from Horizon 2020 to Horizon Europe. So very humbly, we wanted to take one step back and look at what we did, what we achieved, and what we have learned here. So who we are, Blumorpho. Blumorpho, we are committed to support the development of new products or new business model for our clients. We are working mostly for large corporates and investors. And we've been involved in smart systems since an innovation action, since the inception of the company. You mentioned Cohen before, but at the creation of Blumorpho, the Commission has been a great support because we have been coordinating the Gate 1 project. And since then, we are delivering some support in Fed for SAE, Smarties, and DigiFed. And today we are introducing this presentation in the frame of Smart for Europe. So what is our challenge? We mentioned it before, we have to support the digitalization of European SMEs. So why is it a challenge? In fact, when you are managing an innovation action, you can be in a very uncomfortable position because your job is basically to connect state-of-the-art technology, which are coming from the research organizations, the top research organizations in Europe, and SMEs, which are maybe not very savvy in electronics and do not really understand how European projects work. So that can be a little bit tricky. So what are the instruments that we had through Horizon 2020 in smart systems? I will just focus on the one that I particularly know. In the Gate 1 project, we initiated a relationship between research organization and SMEs, and that was done in a win-win partnership. There was no money for the SME. That was mostly a development performed by the research organization. In the single experiment that was developed in Fed for SAE or like in Smarties, we had access to the great tool of cascade funding, and we could then create really a close collaboration between research organization and SMEs in a co-development. This model is also used in DigiFed, we just seen that before, but we also have something new on which I would like to elaborate today, which is a twin experiment, which is enabling the collaboration between a tech provider and an SME, an external SME. Here, the research organization is delivering some coaching and support in this development, but the technology is not specifically coming from a research organization. So who are the companies which are applying to these instruments? So most of the companies which have applied to Gate 1, Fed for SAE or Smarties, cascade funding is attracting a lot of startups and design houses, but mostly startups. And in fact, in DigiFed, in the twin experiments, we have startups, design house or integrators, you name them, and they work in partnership together with more established companies, more established SMEs. So what did we do in Gate 1? In fact, these innovation actions are working like accelerators. So in Gate 1, we were really working very closely as an acceleration model, and we have been the first accelerator to support the of a new company called Movela. Among the 55 projects, 50 companies are still active today, so which is not bad after the situation we are living now. A quarter of these companies have been acquired, so which is also good because if you consider an accelerator like an investment, the next step is investment by VCs. And 11 million euros have been raised in the last 12 months. And we are very proud that we have this success with the Innovation Radar Prize, which led to the creation of Bank for Health, which is a startup. And yeah, this is what we achieved in Gate 1 project. In Fed for SAE, which has just finished a few months ago, here on the left, you have the status of technology readiness level. We have 4 groups, and on the right, you have the business core that we have produced at the very beginning of the project. So before they start, all the companies have been scored. After a 1 hour interview, we have been able to produce this score on 6 different criteria. And on the left, that's the result at the end. And we see that the group 1 is about 41% of the companies supported. In total, 32 projects in FED4SAE. So 9 to 10 projects were already selling products before the end of the project. So this is really an important aspect, reaching the market. When they started, some of the companies were only a handful of people with a lot of potential. And when they left the project, they were selling. In the next group, which is plus 37%, we consider that the commercialization will take place in 1 or 2 years. Either there's more work needed, or maybe there's medical products that takes more time. So in the group 3 and 4, this is more uncertain, there are more risk, or maybe the development were not simply successful. But 80% of the projects have reached a product maturity, almost a product maturity. And the 2 groups which were really so successful, we can see that they had already a business score which was higher than 4. Maybe between 3.8 and 4, there's not much of a difference. It's normal because we didn't want to select the companies which had a business score which was too low. But you see that the selection is really key in the success of these innovation actions, and the business vision needs to be challenged. So here, that was. Yeah, let's move on. So since most of the applicants are startups, do we really support the digitalization of European SMEs? Do we really achieve the goal? In fact, there's a cascading effect, and that's where the ecosystem is very important. This is in FED4SAE, and Calmia is a company which was supported into a single experiment when the partner was Fortis. And Fortis opened its network and connected Calmia to a local company called IBO. So IBO was not paid by FED4SAE, they were attracted to the development. And today, Calmia and IBO have developed a real demonstrator. That's one of the reasons why I was asking about the product passport, because here they developed a blockchain-based passport really connected to the product, which was then demonstrating the origin of the product due to some problems of falsification. So here, this is how an ecosystem can be really helpful. The research organization make the connection with the potential customer. There are other stories, nice stories like that, but wanted to focus on this one for today. So if we try to take, again, one step back on all these instruments, in gate 1, we were at a technology readiness level, which was fairly low at the beginning of the project. And we were looking for a use case scenario with companies, with technologies which were considered as orphan technologies. So, but the cross-fertilization potential was very high because from one use case scenario, you can address multiple markets. So here we were still in the infancy, and all the technology was owned by the research organization. For the single application experiments, the degree of maturity of the technology offered is a little bit higher. We also are using some platforms coming from large corporates, so this is a very high degree of maturity. And the time to market is much shorter. And here we have a focus on a market segment. So the cross-fertilization is still possible, but it's a little bit narrower. And again, for DigiFed, if I focus only on the twin experiments, since the technology is coming from an integrator, it's maybe less advanced than what you have into a research organization, but it's even closer to the market. And here we are almost focused on a client need. So here, this is, in terms of selection, in terms of exploitation, the more you are closer to the market, the closer to the market you are, the easier it is for us when we do this assessment. And we have seen that the selection is very important into an accelerated model. But we really need to pay attention that what is designed here is not just a one-shot case. It must be, there must be some other possibilities. So in terms of adoption, if we look at the adoption curve, which is this bar, we see that we are addressing in Gate 1 in this win-win experiment some innovators, in FedForestry as well, and a little bit of early adopters thanks to the connection with the research organizations and the opening of the network, and of course all the business support. And in DigiFed, we are addressing a small fraction of early adopters, SMEs. But what about the early majority, the late majority? There's still a lot of work to do. And that's where we believe that Digital Innovation Hub have a crucial role to play. We have conducted a survey on 30 different digital innovation hubs involved in artificial intelligence, and we were asking, what is your priority? Startups, SMEs, or large corporates? And for 85%, priority is on SME. So we believe that among the 4 missions that you need to have if you want to become a European digital innovation hub, the innovation ecosystem and networking is of utmost importance. And that's where we think that in the innovation actions, we can identify the front runners. That's very important. We can continue to support the startup because there is a cascading effect of the innovation towards the ecosystem of SMEs, but to educate the large majority, the European DIH will be really important to make a kind of showcase of the success of frontrunners. Because the companies which are SME in region, they will never go to Europe. They will not try to go to Europe to come to find funding. But they want to be educated by their peers. And that's where a local company which have been successful can demonstrate what they have done. And there's a need of a relay between the front runners and then the large majority. And what's next? We talked about the Green Deal, and it's even harder here because we have not finished digitalization, and we need to connect the digitalization to energy transition and to all the circular economy that we mentioned before by Petra. And in fact, we think that the customer traction will be key. At the top of the value chain, there must be a demand, and large companies have managed to ask for smaller businesses to develop their quality system. Now they receive this traction to generate more digitalization. So this is coming from the top. And the SMEs will do this transformation if there's a request from their customers. And we believe here that the business model will be key in the collaboration between the SMEs, the mid-caps, and the large companies. So that was my message for you today. So thank you very much, and I'm happy to open the discussion with you.
Thank you so much, Regis. We have time for a couple of questions. Maybe Regis, practically, how do you see this connection between what you call the front runners and regular SME? Okay, they can show examples, they can testify, but is that all? How practically will you do that?
Practically, there must be some kind of meetings somewhere. You must showcase, you must communicate. There's a lot of communication effort here, and maybe some visits to the front runners. Show how they have reorganized maybe their production, how they have reorganized their organization. So right. How the digitalization created benefit.
Thank you. Any other question? I don't see any question in the chat. Okay, I think, thank you, Regis.
Thank you very much.
Well, all set. Thank you so much. So we'll switch to the next talk, which is this issue about training and recruiting and attracting the young people into this field of smart systems. So this is I think this time the presentation will be pre-recorded, so the presentation is by Knut Aasmundtveit. So Knut got his engineering degree from Norwegian University of Science and Technology in 1999. And then he became a system design engineer at Alcatel Space in Norway. And finally joined the University of South System Norway in 2004, and he is now a professor in micro and nano systems technology, and he will show us how they joined forces with a few other European universities to propose what I think is an enticing master program in smart systems. So, Carola, if you can start. Thank you.
Dear audience, my name is Knut Aasmundtveit. I'm professor at the Southeastern Norway, and I will now speak about the master degree we give together with two partner universities, where we educate engineers for the smart systems industry. This master degree is given together with Aalto University, Helsinki, Finland, University of Southeastern Norway, which I represent, and Budapest University of Technology and Economics in
Yeah, something is not working, Carola. I don't have sound.
I'm also available. I can give a talk live if that's preferred.
Yeah, maybe. I see the slides, but I cannot hear you. So.
Yeah, the video was fine when I listened to it, but if you fix it, that's fine. But if not, I can step in and do it live.
Yeah, if you would, yeah, that would be nice. Great.
Okay. Shall I share my presentation?
Yes, if you can do that. Carola, is that possible to do that? Or you just comment on the slide we are seeing, whatever, Knut.
Yeah, or if I do like this, are you now seeing my first slide?
That's good.
Okay. Thank you for the introduction, and it's a pleasure for me to speak about our joint international master in smart systems integrated solutions, where we, together with other European universities, aim at educating engineers for the smart system in the industry. So we do this together with and do you see me changing slides?
Yes.
Yeah.
No problem.
So I'm from the University of Southeastern Norway. We are the coordinators of this degree, and we give it together with Aalto University, Helsinki, Finland, and Budapest University of Technology and Economics in Hungary. The master degree is structured such that the students actually move between the different universities. So they have the first semester in Vestfold in Norway, second semester at Aalto in Helsinki, and the third semester in Budapest, and then they take the fourth semester where they have their master projects at any of the three partners or at an external. The program as it is new, starting up now in the autumn 2021. But we build heavily on our prior experience with the joint master in smart systems integration, which has run all the way since 2013, where Ribot University in Edinburgh was also partner and coordinator of that. We're happy that EPoSS is associated partner of our joint master, together with main industry clusters or research organizations in the 3 countries, together with also universities in other countries and industrial companies, primarily in the 3 countries, but also in other countries in Europe. We're happy to say that we could actually make this mobility happen also now during the COVID-19 problems. So students have been able to move also these last 2 years. The study we have in smart systems integrated solutions builds heavily on microtechnology and microelectronics. We combine the expertise we have in the different universities, so none of us would be able to give the total breadth of smart systems integration on our own, but together we build something we think we are confident have more value and is better than what we could do just by ourselves. When we say integration, we think both on the physical integration in terms of assembly packaging and the functional integration. I saw in the first presentation that both these words were actually used, so I'm happy for that. Also, importantly, the fact that the students move between these 3 different universities, 3 countries in Europe, means that they gain a cultural experience, cultural competence, which makes them very well suited for working in an international working environment. There's a specific course schedule. I'm not going in detail for all these courses we are giving, but I will say a little bit about what is new in the program we have now compared with the program we have run since 2013. One thing is what we call the SSI Design Lab, which is a group project which goes across the 3 semesters of with different parts at the different universities. So they can actually, the students develop smart systems on their own, more or less from scratch, and also involving the business case, not only the technology. We also have increased the focus on sustainability and reliability, some dedicated courses. And we have included a course which is built directly on industry cases, different primarily MEMS devices, but where also there are then guest lectures from different industrial companies. What do we want from industry in this? We want a very close involvement with industry, and the associated membership of EPoSS is one way of implementing this. We have an industrial advisory board where we are now looking for members. So that's one thing. We are the students shall have an internship between the first and the second year of their study, and we want as many industrial internships as possible there. We also encourage master projects to be carried out in industry, and it's also possible to have for if industry wants to grant scholarships for students, we of course welcome that. In the course of the semesters, we involve industry in the form of guest lectures, company visits, and we will also, in particular, have coaching of these student projects. This SSI Design Lab, as I mentioned there. And particularly at these 2 occasions, we have the summer school, which we have between the first and the second year of the study. That's at Lake Balaton in Hungary. And new from 2022, we will also have the winter school, where we will also involve industry representatives, and that will be in the Norwegian mountainside. So these summer school and winter schools, in addition to the technical program, they are also important meeting places, and has been crucial to build an atmosphere of mutual trust between the partners, and to really benefit of the different the expertise from the different universities. I will also mention what we have just started for the summer school. The students have got a one-day challenge that they shall create a startup company, and at the end of the day, they shall test how they will sell it to investors. Last thing we of course want from the industry is to employ our graduates. And to say a little bit about these graduates, the study itself has the Erasmus Mundus status in the European Union. This is a strong quality label. EU gives scholarships to students, which makes sure we get a large number of applicants, very good applicants. So the number we admit is in the range of 20 per year, and very cross-cultural, more than around 15 nationalities. This is partly based on the scholarship policy EU has, with so there's a distribution on nations. Both European, Asians, and the Latin Americans have been quite a few. We have for the ones we have graduated, they almost 100% has been employed, mostly in Europe, and the whole range of companies from startups to large companies, and some even starting their own company. So I have Sophia here as the example of one that actually started her own company. So with that, I want to thank you for the attention. Here's a little picture gallery of the main people involved from the 4 universities involved, I would say. And with that, I'm happy to receive questions.
Thank you, Knut, and sorry that you had to do double work, pre-record and do the real thing, but it it was fine. Thank you so much. Is there any question for Knut? Okay, yeah. There is a question from Henry Hajmanbach. So students look happy for those 50% students pursuing beyond master. Which PhD topics and locations are most popular?
That's a quite wide range. At our own place, we have a handful of PhD students. We have a couple that has graduated as PhDs. So yes, there's been PhD students and graduates at Ribot in Scotland, and at ourselves at University of South Eastern Norway, also some at Budapest, but also at a number of different institutions. I know in KU Leuven there's been, and there's been at Swiss universities, and I believe there was one at a Canadian university. I don't remember quite which. So that's been quite some scatter. And the topics has then been well, quite varied, different MEMS projects. The most recent was I can record was one of my own students, who was one of the graduates from this joint sponsor. graduated just before Christmas now, working on carbon nanotube integration in CMOS for gas sensing applications, as an example.
Okay. Thank you. I have a question, Knut. Did you do a survey within the students to understand what they like most and what they didn't like so much, and what do they think are the strongest features of your master?
They are we do questionnaires every semester, so to get kind of constant feedback to iterate how to work here, particularly because there's been a need to coordinate the structure between the different universities, and I can say that what they are particularly happy about is this the way the class feeling they have coming from all these different nations and moving around with in the different countries. It makes these students much more dedicated than the regular student, I would say. It's both about feeling that they call themselves the SSI family, that they are family. And we see it in the results in exams. They get better results than the average students we have, yeah, and they also I'm not sure if that answered the question, but
yeah,
at least.
And is there something that they would like to change?
There has been when it comes to course level, it's always things which are they have comments, and sometimes we change, sometimes we have or at least in the start when it started in 2013. There was a challenge to have the transition between the different semesters correctly to avoid having holes in the criteria. Like we in Norway had the second semester, and the first semester was in Scotland, and then for us to understand the details about what they were taught the first semester, to not repeat things on one side and not assume knowledge they didn't have. I mean, the first year we did some mistakes, and we have iterated towards better coherence.
I have also a question. First of all, many thanks, Knut, for this very interesting presentation.
Thank you.
I think you said that graduates are involved from 12 countries or more, but how many? In order to understand a little bit more about the impact, how many graduates did participate or do participate in the initiative?
The graduates, let me see, we have had like between 15 and 20 per year, more or less. And since the first one came up in 2015, so we have had 5 editions, which are or 6 editions, which are graduated. So we are, yeah, if we are somewhere above 100.
I see.
Okay.
Okay. Why did you limit to 20 students per year?
There are 2 limits. One thing is that there's EU gives scholarships, and that's a limited number. Okay. We also have self-funding students coming in, but in the first years we had very few of those. It's been slightly more, but that's limited. We have now in a new program, we have set a threshold on 30 for which is really lab capacity. Yeah. At the different because we we do very intensive lab work here with the students, which we think is good, particularly when they are going out for work in industry. But we also use the research labs, which requires that you have a very close supervision. So it's resource demanding to have many students through the lab.
I think we have one final question, but we'll need to answer fast. Are your students also working on medical applied research, and how many students are involved at this time on the medical?
Yes, thank you for the question. Indeed, we have in the second semester they can choose between two tracks, and one is well, cyber physical systems with MEMS based, and the other is micro nanobiological systems. So it's also implying medical or different versions of biological systems. So it has varied a bit from year to year, sometimes half and half, sometimes, but in general half and half. And also for master projects, some of those which take kind of the more cyber physical, they end up taking master projects using in ultrasound transducers, for example, which will then be medically related. So yes, we have a good number which goes that direction.
Okay, thank you so much, Knut. So if you have other questions, you can still interact with Knut using the network tool we have. Thank you, Knut. So we move on to the final presentation. So Petra, I think, introduced 5E project, and now it's time for the award ceremony. And I will leave the floor to Fabrizio, Fallarini, and Serena Zerbinati from MESAP Innovation Cluster. Fabrizio, Serena, the floor is yours.
Thank you very much for the introduction. Can you hear me? Is everything okay?
Yes.
Okay, thank you. Good morning and welcome again to everyone in this session dedicated to the 5E Contest Award ceremony. My name is Serena Zerbinati. I work for MESAP Innovation Cluster in Italy, focused on smart products and smart manufacturing. I'm here today because MESAP is the leader of the 5E project outreach work package, and our aim is to provide support, promotion and dissemination to innovators of the 3 European electronics ecosystems in nanoelectronics, flexible, organic and printed electronics and electronic smart systems. And in this framework, we have organized and run the 5E contest. Next, please. The contest wants to celebrate excellence in electronics and give visibility to European electronics innovators, providing them with public recognition as widely as possible for their value, innovative contribution and impact at European level. It spreads awareness on innovations in the 3 electronics areas covered by the 5E project, highlighting in particular the concept of convergence among the 3 electronic areas and at the same time the concept of functional electronics developed within the 5E project. Together with the contest, another concrete tool that we have developed within the 5E project is the 5E Digital Showcase, as Petra previously introduced. It is an online platform open to all electronics innovators and dedicated to the 3 electronics areas of the project, where it is now possible to discover more on about 50 different innovations and their features. And you can find it directly on our 5E website. Next, please. The contest covers 3 different categories of winners. The first one is dedicated to the best electronics product developed in-house by any interested party, such as startups, SMEs, large enterprises, RTOs, but also user communities and the wider public. The second category wants to point out the best electronics product developed in the context of a funded project at regional, national, or European level. And the third one, as you probably know, is a special category designed to highlight the concept of convergence among the three electronic areas. In this specific case, the participation was automatic for each contest applicant who flagged at least 2 different electronic areas for their product during the application. Next, please. The applications were evaluated by a board of 8 external technical evaluators representing the European Electronics Industrial Associations. And for each application submitted, the jury gave a score from 1, very poor, to 5, very good, in 4 specific evaluation criteria that are the innovativeness of the solution, the level of impact of the solution, the level of convergence among the 3 electronic areas covered by the 5D project, and last but not least, the relevance with the 5D project results and output, concerning in particular the joint vision, the functional electronics concept, and the 4 vision papers developed within the 5D project. Next, please. Thank you. This is the first time running the 5D contest, and we have seen a significant participation and interest. We received in total 33 different applications, which are divided between categories and coming from 10 different countries. I would like to take this opportunity to thank again all the participants for their involvement and their participation. Next, please. So, without further ado, I give now the floor to my colleague Fabrizio Fallarini from MESAP for the main part of the today's session. Fabrizio, the floor is yours.
Thank you, Serena, for your presentation and for explaining the 5D contest. Now it's time for the public announcement of the winners, and after the evaluation done by 8 European experts in electronics, I'm glad to communicate the 3 winners. First of all, I want to underline that it is not a kind of gold, silver, and bronze prize, but 3 golden winners. Next, please. Okay, here we are. Category 1 winner is the Sustainable Multifunctional Biphase Sensor from Silicon Austria Labs from Austria. Category 2 winner is Sensis, the electrochromic fish from VTT Finland. And category 3 winner is the Lilith from Hype, Italy. Congratulations to all of you for this important achievement. I send you my virtual applause on behalf of the 5D Project Consortium with the hope of doing this kind of event live in the coming years. The winners were already aware of the results, but this is the first public announcement, and we are proud to make it during this major European event. Next slide, please. Okay, we start from category 1, the best electronics product developed by an interested party. I will now hand over to Ms. Joanna Zikulnik from Silicon Austria Labs, who is going to tell us about the Sustainable Multifunctional Biphase Sensor, a sensor that optimizes performance and minimizes material consumption by double-set printing. Okay, Ms. Zikulnik, the floor is yours. Thank you.
Thank you. Next slide, please. Hello, my name is Johanna Zikulnik, and together with my colleagues Lukas Rauter, Thomas Moldaschel, Martin Lenzhofer, Shergil Khan, Lukas Neumeier, Sabine Lenger, and Jürgen Kosel from the Research Unit Sensor Applications of Silicon Austria Labs, we developed a sustainable multifunctional biphase sensor tag. Next slide, please. The biphase sensor has been manufactured on uncoated paper substrate. Due to the double-sided design, the material consumption is reduced while optimizing the performance. To be more specific, the tag includes a printed antenna, a passive NFC chip, which means that no battery is required, as well as printed environmental sensors for measuring temperature, humidity, and strain. Next slide. Next slide, please.
Yeah, it's coming.
Oh, so sorry. The development of the presented sensor tag was mainly driven by environmental considerations. Basically, the fastest growing waste stream in the European Union is electronic waste. And concurrently, the number of sensors deployed increases at high pace, which raises urgent demand for sustainable and green sensor solutions for the future. Those challenges are addressed with the development of our multifunctional sensor tag, taking into account the sustainability of the fabrication process and the device itself by employing additive manufacturing technologies and sustainable materials, namely uncoated commercial copy paper. Next slide, please. The benefits of the presented technology are, on one hand, the efficient use of resources. Uncoated paper substrate can be considered as renewable raw material, and the double-sided design reduces the consumption of resources. In addition, additive manufacturing is also considered to have low environmental impact, and the passive NFC chip doesn't require external energy, so no battery. In addition, the sensor is highly versatile. The platform is designed in an adaptive way, which means that it can be equipped with different sensors depending on the individual sensing requirements. And the digital manufacturing technology offers high freedom of design as no stencil or special equipment is required. At the same time, the device is low cost due to the used paper substrate and the efficient use of resources, while inkjet printing enables cost-efficient manufacturing even at small batch sizes, as it is a digital manufacturing technology and we don't need stencils. Next slide, please. To give some more detail on the manufacturing process, a Bixtro LP50 inkjet printing platform equipped with a Spectra S-Class printhead assembly was used for the inkjet printing, and the conductive traces were realized using silver nanoparticle ink, and the device was then cured by means of intense pulse light annealing. For the bifacial design, through connections have to be realized. More specifically, the holes were manufactured using a laser, and then the wires were subsequently filled with silver screen printing paste and then thermally cured. And the silicon chip for the readout was then adhesively bonded to the printed circuit. Next slide, please. Here we see just a short, I hope you see it. Yeah, a short demonstration of the functionality of the sensor tag.
Do you see it?
We don't see it, I think.
Okay, I see it on my screen, sorry. Just let me, I show you the, okay, sorry. Now you see? No?
I think it takes some time.
It takes some time because I see it on my screen, but you don't see it. Okay. Sorry, yesterday it worked. Okay, then I just go back. Sorry for that. So, do you see my slides?
Not yet.
Carola, wir sehen dein Bildschirm von der Session.
Yeah.
Jetzt.
Okay, now it's coming up.
Okay.
Sorry.
Yeah, it's not an issue. The video was just should have been a short demonstration of the functionality, which you also see here in this static image. That the data can be very easily be read out with every commercial smartphone that provides NFC connectivity. So basically, it is available to everyone, basically. Yeah, we consider to conclude this presentation, we consider the multifunctional biphase sensor as game changer for universal sensing tasks. In the future, we will be further developing the sensor task depending on industrial needs, for example, for the usage in harsh environments or condition monitoring, for example, in the food industry, by embedding the sensor device into biocompatible and low-cost embedding materials such as EVA foil. Yeah, thank you very much. Next slide, please.
Sorry, my computer is okay.
Thank you so much for your attention and for the award. Thanks.
Thank you, Ms. Zekelnik, for this insightful presentation. And now, and passing now the category 2 winner, the best electronics product developed in the framework of a funded project. We have now Mr. Thomas Kraft with us today to explain a little about the Sensis, the electrochromic fish. We talk about a platform represents cutting-edge printed electronics in the form of a multiple printed sensor systems. So, Mr. Kraft, thank you, and the floor is yours.
Great. Yeah, thank you very much, Fabrizio. Next slide, please. Yes, so today I'm representing Decochrome. It's an EU H2020 project. I encourage you all to visit decochrome.com. I'm from VTT in Finland, the Technical Research Center of Finland, and I'm a senior scientist with the Printed Material Systems team. And we're in this unit of printed intelligence. And in the Decochrome project, we're bringing life to these electrochromic displays in these integrated systems. The Sensis electrochromic fish is a development between VTT, Invisible, and the University of Lapland, who are all project partners within Decochrome. That involves about 15 project partners. Next slide, please. So Decochrome, it's the decorative applications for self-organized molecular electrochromic systems. It's a 4.5-year project that ends next June, in June 2022, and it began in 2018. And the coordinators are from Finland, the University of Lapland. And in this project, we're bringing electrochromic, we're developing electrochromic materials for system applications and manufacturing consumer products. And one of the key cornerstones of the project is to really bring electrochromic display manufacturing to the arts community and the design community. So we have a lot of industrial designers involved in the project. And we're empowering these creative industries to bring aesthetically pleasing, practical interfaces, human-computer interfaces, to smart goods and environments. So please check out our website. There's also a Facebook group and the handle on Instagram at Decochrome. You can also check out these YouTube videos. One really interesting one recently came out. It's this thermos flask. We're not going to watch it today, but I recommend you all take a look at it. Next slide, please. At VTT, we do printed intelligence manufacturing, starting often from lab scale with the implementation on roll-to-roll pilot lines. I'm coming to you from Oulu in northern Finland, but we have offices throughout Finland. But in Oulu is where we have our pilot line facilities. At VTT in the printed intelligence, we're doing printed components like organic photovoltaics and perovskites, batteries, and then we're making systems using hybrid electronics, so combining printed and traditional electronics on flexible foils. And this can all be done in a roll-to-roll process. And then we also do post-processing, including lamination, laser cutting, injection overmolding, and testing. Next slide, please. Sensis. So Sensis, it really is a beautiful a beautiful integration of many printed components to make a hybrid, smart, integrated system. And what we've done here is we've printed a backplane that includes capacitive touch sensor and an NFC antenna. We're printing a temperature sensor and a force sensor. And we've also, in this particular demo, included a plug-in power source and a battery power source. And the key feature to make it relate to the Decochrome project is the integration of these electrochromic visual indicators, which are also printed in a coplanar fashion. We have 3 indicators that will indicate which sensor is active. You can toggle between the sensors, the antenna, the temperature and force sensor, with a touch of the capacitive touch sensor. And then depending on the signal strength for the temperature and force sensor, you're going to illuminate these fins on the fish. So depending on the signal intensity, which can be pre-programmed, you'll have a different range that correlates with 1, 2, 3, 4, or 5 fins. And then the NFC antenna is sort of a wake-up function for the device. Please, next slide. But the key here, and I really want to emphasize this, is why does it look like a fish? You might think, might make you chuckle, or it might make you think, oh, it's beautiful. And I hope it's the latter. The design community in the project, we came up with a few different ideas for what could be interesting to the user. And in the end, we chose this fish. And how can you make an integrated smart system on a fish backplane? Well, that's where Invisible and VTT, we work together on the electronics and the printed display elements. And of course, we designed a sequential manufacturing process where you can do this all in roll environment eventually, but this was done in a sheet-to-sheet process. And then once everything was mounted, then we did overmolding at VTT, where we put this flexible hybrid system in a mold for an injection overmolding, and you can form a structural element in this process to have your product. And here you can see I'm using the force sensor on the bottom, pressing it, and I've illuminated the three channels on the 5-channel display on the fins. Next slide, please.
No.
Yeah, so this is the last slide basically of the presentation, in case you're getting fidgety. But this is really just showing some of the processing that we did at VTT to prepare the Sensus demo. First, we mounted, after printing all the elements, so printing all the sensors, the backplane, the display elements. Then we did assembling on our bonding line of the traditional components to make the hybrid system, to give it some intelligence or some programmability. And then we were able to put it into this mold cavity. Now, depending on the type of system, there's furniture made of plastics, garbage cans, so you can design any mold you like eventually for your product. And then you can just design electronics to fit within that mold. So you can have curved mold of any shape, and then you can overmold it. And of course, depending on the requirements, you can have different types of plastics like polycarbonate, PMMA, or polyurethane, which we used in this case. Next slide. So with that, I hope there's some designers out there, and especially industrial designers, who are really thinking about how to make the products of the future. And how will you design the next integrated smart system? I think there's a lot of high TRL level technology available, and I really throw it over to you to come up with the next generation product. So thank you, Decochrome, and thank you, Invisible, University of Lapland, and all my colleagues at VTT. This would not have been possible without everybody's involvement. Thank you very much, 5E, for this award.
Thank you, Mr. Kraft, for this interesting insight. Thank you very much. And I now pass the floor to the last, but not means the least important winner, representing category 3, best electronics product convergence among the electronics areas. The Lilith product is an automatic and autonomous intervention system in the event of violence against women. The product is characterized by convergence between the areas of flexible, organic, and printed electronics and electronic smart system, responding to the functional electronics concept mentioned before. This product was voted the best of the 33 participants. Thank you, Mr. Zakaria Kogo, and the floor is yours.
Hi, good morning, everyone. First of all, I want to thank 5E for the recognition you gave to our project. It's very important for us because it's a proof of the validity of our idea and the great recognition to the efforts we made to to build up this project. You can go off to the second slide, please. Next. I would start with a very brief introduction of Herve. This group, formed of 5 founders, started collaborating in 2017, and they founded officially the company Herve Design in 2019 as an innovative startup. To date, Herve has roughly 23 people, including permanent and occasional collaborators, and holds ownership of various IP, software, and industrial designs. Our vision is to shape technology around the user, providing innovative AI-based solutions to daily needs. In 2018, aware of how much there was and still is to be done in terms of social awareness and struck by the countless reports, we set ourselves the drive on making our contribution in fighting violence against women. So we started figuring out some scenarios. Imagine if, like Julia, a bus driver who often works the night, could feel safer knowing that in case of danger or aggression, someone would be able to promptly intervene. Or for example, Emily, who lives in a dangerous neighborhood of a big metropolis, could come back from her shift without feeling much fear. And again, for example, Jennifer, after an exhausting day of work, who wants to go for a long run in the park, could do it without feeling in danger. Please, next. So to allow women to feel safe and protected in every situation without the surplus of an object to be actively triggered for defense, we have designed a protection system that integrates cutting-edge technologies into something common, such as clothes or underwear. So Lilith is an automatic and autonomous individual protection system that collects kinetic and biometric data directly from the user's body, sends them to pair devices in which an app that analyzes them and recognizes situation of danger, malice, or violence is installed. The focuses that drive us in the development of the solution are mainly invisibility, like to allow effectiveness and activity of intervention, the device must be invisible to the aggressor, so we cannot identify it and neutralize it in any way. The comfort that allows the spread of the invention in order to be able to work without limitation and discomfort for the user, and autonomy and automatism, like victims of violence are often unable temporarily or continuously on a psychological or physical level to ask for help. So the system must be able to independently recognize the context and activate the alarm without the need of the user intervention. Next, please. In order to comply with these guidelines, we developed, in partnership with the fashion designer Silvia Actis-Perino, a range of smart clothes, and more specifically, an underwear body and fitness suit to be paired with mobile app based on artificial intelligence algorithms. Next, please. The body has inserts of conductive fabric made with natural and synthetic fibers coated with micrometric metal layer, which form capacitive and resistive sensors capable of picking up biometric signals such as heartbeat, respiratory rate, body temperature, sweating, and galvanic skin response. The sensors can also pick kinetic signals, for example, punctual or diffuse pressures, accelerations, positions, rotations, etc. And all these signals are sent through a specifically designed communication unit to the mobile app, which has the task to analyze and compare them. The communication unit has been designed to be made with flex PCBs and miniaturized components in order to not affect the fit and comfort of the body. Next, please. The mobile application uses proprietary neural algorithms similar to FNNs, feed-forward neural networks, for stochastic motion recognition, which can be executed by the hardware of a common smartphone and tablets. The incoming data are cleaned, analyzed, compared with each other, and classified with sample data sheets. In case of compatibility with a dangerous situation or violence, an alarm is sent to a series of contacts preset by the user. To optimize the system outputs, with each new use, the sensor and analysis datasets are recalibrated to provide a new starting point that guarantees greater robustness and reliability to the system. As an additional feature, if the system, due to malfunction or technical impediment, fails to forward the alarm, the application will search for other iterations of itself installed in traceable devices within a predetermined area, and will connect to them, creating a local mesh network in which every individual node will attempt to relay the alarm. Once the message, which is encrypted to the nodes, has been forwarded, the network is deactivated and no trace remains to the nodes. This way we ensure that target contacts receive the message and can take action quickly. Slide 7, please. Thank you for your attention. We remain available to anyone who wants more information and details on the project. You can find our references at the end of the presentation. For any question or insights, you can write to the addresses info@hyve-design.it or gm@hyve-design.it. Thank you very much, 5E, for the premiation, and good continuation to all.
Thank you, Mr. Kogo. And thank you very much to all the winners that share their amazing innovation, and we are very proud to have them on board in the 5E project final stage. Finally, on behalf of the 5E project consortium, I'd like to take this opportunity for a special thanks to the SSI conference organizers for giving us the chance to share this electronics innovation, and also to thank the audience taking part in today's event. And as you can see in that chart, there are our contact details and the 5E project website if you need further information, and where you can find the showcase mentioned before with 50 products showcased. So thank you very much to all of you. And I don't know if there are some questions for the winners area. Thank you.
Thank you, Fabrizio. This was really compelling demonstration of what functional electronics can do. That was really enjoyable. I don't know if we have any question. I don't want to run late because I know there is the topic table starting at noon. But if there's any question, maybe we have time for one question. Let me know. I think this is good. So thank you so much. So for the next session of track 5 will be tomorrow morning, I believe at 11 with Wolfgang and myself again. And now we have the topic table, I think, on energy and also on digital innovation hubs, so they should be started anytime now. Thank you, Carola, for taking responsibility of all the logistics. That was flawless. Thank you so much.
Yeah. You're welcome.
And I think we are done for this morning.
Yep. Many thanks.